Hello guys, so this will be our second lesson in terms of programming. Right now we'll be looking at counters. Our main topic is counters and the while loop. But before we get into the while loop, I would like to show you what counters are. Okay, so let's start. Okay, so counters. What do they do? Oh, by the way, you'll have this presentation up in Classroom uh, along with this recording so that you can review this in your time. Okay, so what do counters do? Well, as their name implies, they count. But you might ask, what do they count? Well, basically, they count whatever you want. Generally speaking, programs go from the beginning up until the end in a linear fashion. That means that they move forward and they move only forward. Okay, they move from the beginning and they arrive at the end. We've seen this in past examples that you give the program some value and then it returns that another value and the program is finished. But there are some cases when you want programs to run within loops. Okay, what does that mean? Well, basically you want the program to run over and over and over again. So counters become super useful when we go into loops. Why? Because they can count how many times we've done a certain loop. Okay, so here we say they are generally used to count the number of times. Let me change this number of times the program cycles through a set of instructions. Let me correct this. Okay, so what does that mean? Well, basically, if the program is going forward and it goes with inside a loop, so it continues forward and it reaches a point where instructions can be cycled, so that instructions can go over and over again. Counters help us decide how many times we want that those set of instructions to be done in a repetitive fashion. Don't worry, we'll look at an example at the end of today's presentation, but that is the general idea. Counters help us count how many times we've done a set of instructions, and therefore they help us to break that loop, okay, so that we can continue. Because remember that programs must have a defined end. So if we go into a loop and we don't exit that loop, then our program doesn't work because we went into an infinite loop. Okay, they can also be made to move through registries in arrays of data. Don't worry too much about this. I'll explain it in class if you're curious. We won't be looking at this. We won't be working with arrays in this course, but if you're curious on what that is, message me and I can tell you what it is. This is important. They are internal variables, okay? Therefore, that means that once the program is completed, they get reset, okay? The user will never input a number for a counter. The counter works automatically without user input. Therefore, it's an internal variable, only to be managed by the program itself. The user, I'm going to repeat myself, the user does not introduce a counter. Okay, counters are internally defined, they are internal variables. Normally, once a loop is completed, they get reset so that they can be used again. Okay, so let's continue. Where are they used? Well, as I was talking in the past slide, they are used within loops. Okay, so programs generally work in loops, and counters help us determine the amount of times that loop is executed. So, remember our last example, the one that was, what was it? Oh, that given a number, a program would tell you if that number is even or odd. So we would want that program to continue indefinitely, right? Well, maybe not, but maybe yes. Maybe we would want that program to be running, and we would be giving that program numbers, and it would be telling us if that those numbers are, uh, how do you say this, even or odd, right? So maybe we want to define for some reason that we want the program to work only, let's say, 7 times, or a specific number of times defined by the user. Well, we would put the program within a loop and we would put a counter inside that loop so that once the counter reaches the amount of times that we want the program to loop itself, then it would exit the program. Okay, so they are generally used to count how many times a cycle, how many times a set of instructions has been executed, okay? So how many times we go through a loop. This information might be relevant for the programmer or the user. How many times we go through a loop might be relevant for the programmer or for the end user. It depends on whatever program we're working with. So let's look at the basic language. Uh, this language, let's say, mm, it depends on what type of programming language you have. It's basic, and you know what? Let me change this because it's not language. It's basic syntax. Syntax is how we write things. Okay, so we generally define counters as variables, and they are generally named I, J, or K. Don't ask me why, but that is how it is. It's normally it's commonly made like that, I, J, or K. Okay. Uh, so these variables, the counters, increase the value of I, the counter, in increments of 1. We could, if we wanted, to increase in values of 2 or 3 or whatever. So this is the basic syntax. I is equal to I plus 1. So each time that the loop happens, that we reach this instruction, we take our value of I plus 1 and store it in I. So now I has effectively increased by 1. Another syntax that we can use is I plus plus. I plus plus is exactly the same thing, adding one number to I every time that this instruction is read. If we wanted to do increments of 2, we would do something like I equals I plus 2. So every time we reach this instruction, we would increment the value of I by 2. We could also do I equals I plus 3 or plus 5 or whatever, okay? But these are in essence how counters look. Now let's look at the while loop. This is important because this will be our instruction to let's break the linearity of a program. So programs generally run from end to finish and that's it. But we can put while loops within the program so that the program repeats itself as many times as we want and then it ends, okay? So let's see, what is the purpose of the while command? It tells the program to do instructions while some variable acquires some specific value, while we get some expression. Okay, this will be clear in the example at the end of today's presentation. They are structures used to generate cycles within the program, so they generate loops so that the program doesn't start and finish, but rather it starts, it does a set of instructions repeatedly, and then when we decide it's done, we can input some variable and it would be finished. It is very similar to what we already did yesterday, okay, with the if command. And actually, the while command, if we'll look at the how it looks in a flowchart, you'll see that it's exactly the same as an if command. To be completely honest, what we did yesterday with the if command was very similar to what we'll be doing here with the while command. So let's recap this. While command tells the program to do instructions while, mientras, some variable acquires some specific value. Okay, so for example, this would be the generalized syntax of a while command. So while test expression, so this would be while something happens, mientras algo pase, okay, while something happens, do things. And that's a cycle because while this thing is happening, while this thing is true, then the program will do things. Once whatever we're testing here becomes false, then we won't do things anymore. We will jump out of the cycle. So this test expression is generally something like, I don't know, it could be, for example, while a equals 1, okay? So while my variable a equals 1, you need to do things. If a for some reason changes value, then you break the loop because a is not 1 anymore. So this would be false and we would go out of the loop and simply continue with the code. Okay? So right here in this parentheses, we have the test expression. That means we need to do some logic expression here. And if that is true, if that holds true, then we will do things. If that becomes false at some point, doesn't matter at what point, but if that becomes false at some point, then we exit the loop. So that is basically what the while command does. It's very, very simple. So let's look at one example. This is the example that I came up with because it has both counters and the while command. But here is the generalized structure of the while command in terms of flowcharts. Okay, as you can see, the while command is an array of an if command and processing commands. Okay, processing let's say symbols. Okay, so whatever the program is doing up here, I don't care. But when we get here, we test some expression. We do some logic expression. If that logic expression turns out to be true, we run a set of instructions. And after those instructions are done, we return to our logic expression and test that logic expression once again. If it didn't change within here, then this will be infinite, okay? Because we will always be making a loop here. We will always be cycling here. The only way to break out of this is that in this body of the while loop, we do something to the variable that is being tested here, okay? So in this code, if we're doing something inside here that is changing the value of our variable that we're testing here, then at some point, ideally, this thing, this logic expression here will become false and will break out of the while loop. Okay, so statement just below the while. Okay, so we break out of this and then we continue our code. Okay, so what do we do to break out of while loops? Well, basically that's where counters come in. Counters are super useful to break out of while loops because we can define how many times we want this loop to be done. So let's look at an example right here. So I didn't pay attention and I didn't put a name to this algorithm, but let's read what it does. Okay, so algorithm without title. We have an input box here. The input box is A. Okay, so I'm giving a number. I'm giving a number to my program. This is a number. Okay. I am also doing this thing. I am assigning 1 to this variable called I. Remember, I will always be a counter. Okay? I will always be a counter. So right now, the value that I has is 1. Okay? So then we go into a while loop. As you can see, this thing, it's exactly this thing. Okay? So we go into this while loop and you know what? I don't know if no, I can't pause this. So no, you know what? I'll just continue. So we go into this while loop, and we check. This is our logical statement. This is our like, testing our expression. So is I less or equal than A? So let's for example let me do it here. I'll add a box here. Okay, so we start here, algorithm. We give the algorithm some value A, let's say 3, no 4, let's do it 4. The value that I has is 1. Okay, so we gave the algorithm the value of 4 for A, and we know that I is equal to 1. So we go into this while loop. Okay, so the program asks, while I, which is 1 right now, is less or equal to 4, that turns out to be true, do this instructions. So this in the first cycle, so let's call this first cycle. So while 1 is less or equal to 4, this turns out to be true. Then we print out hemos ciclado, so we print out hemos ciclado, and we print out the number I, which is 1. Hemos ciclado 1. After that, we do I is going to be equal to I plus 1. So I is equal to 1 plus 1. So I now is equal to 2. And we go back here and we test. while 2 is less or equal to 4, this turns out to be true, we print out hemos ciclado plus the value of I. I at this point, the value that it has is 2. Hemos ciclado dos. And we add another value to I. So I will be equal to I plus 1. So this is equal to 3. And we return. Let's check another while loop. While 3 is less or equal to 4, that turns out to be true. We print out hemos ciclado plus the value of I, 3. And now I is equal to I plus 1. So 3 plus 1 equals to 4. Finally, we return here and we check while 4 is less or equal to 4. Yes, this turns out to be true as well because now 4 is equal to 4. We print out hemos ciclado plus the value of I, which is 4. I now becomes 4 plus 1. This is equal to 5. And we return to the algorithm, to the while loop, and we check while 5 is less or equal to 4. This is false now, and since it is false, we finish the algorithm. Okay, so we did a small cycle here, and the number of times we went through this cycle depended on our original value that we gave here, a. If we would have given a the value of 3, then we would have been printed, we would have received the information hemos ciclado uno, hemos ciclado dos, hemos ciclado tres, but we wouldn't have gotten the fourth. Why? Because I would not have been less or equal to 4, okay? To 3, sorry. Okay, so that is basically the while command, and we'll be looking at some examples, probably 2 examples on class tomorrow on Thursday. Okay, so thank you guys for your attention. If you have any questions, please write them down and ask them during class. Okay, bye guys.